The objective of this video is to find the area of a regular hexagon. Okay, so let me draw a hexagon. Say this is my hexagon. Okay, and let's say that the length, as it's regular, so let us say this is say 5 centimeters. Okay, so each side is of 5 centimeters. So the question is, how would you find the area of this hexagon? Okay, so before finding the area, let's see what's the measure of each interior angle. So to explain that, let me draw a line. Okay, so this is an exterior angle. Okay, so here, say, let us say this is say x. Okay, so if this is x, uh, this would be 180 minus x. Okay, so let me write 5 somewhere else. So this is a 5 centimeters. So if you watched one of my other videos, I have proved that the sum of exterior angles of any polygon is always 360. So let me write that. Okay, sum, this is a very important rule, sum or addition of exterior angles of any polygon of any polygon, that means of any number of sides, any polygon is always 360. This is a very important rule. If you take any polygon, a hexagon, a pentagon, or a octagon, if you add the exterior angles, it will always be 360. So if this is x and say let us this is y, you have got how many exterior angles? So I'll draw one more exterior angle. So this is one exterior angle, this is the other exterior angle. Okay, so if this is y, you can understand this will also be y. This is again x. So what can we say about x plus y? We can say x plus y is 360. And you got how many exterior angles? So based on this rule, can I say the sum of exterior angles is 360? So can I say 6y is equal to, oh sorry, I made a mistake, x plus y should be, what is x plus y? The sum of the angles on a straight line. So angle on a straight line adds to 180. Okay, so yeah, this is always good to check. So you got 6 exterior angles and you add them, they will always be equal to 360. So I can say y is equal to, when you divide both sides by 6, that is 60 degree. So I can say this is 60 degree. So how much would this be? Okay, x plus y is 180, so this has to be 120. Okay, is that clear? So each of this exterior angle uh, each of this exterior angle is 60, sorry, and the interior angle is 120. So now what I'm going to do is I'm going to split this. I want to say this is, let me say this is the best judgment. Suppose this is the, you can say the center of the, not the center, but a point which is equidistant from all the vertices. Okay, so and if I draw a triangle here, so let me draw a triangle here. So this is what I want to draw. So can you understand that this hexagon can be split into how many? So let me draw that. So let me show you. So this is one triangle, this is the other triangle. Okay, it's very difficult to draw, so I hope you understand the idea. Okay, so this is the third, this is the fourth, this is the fifth, and the sixth. So you've got 6 equal triangles. Okay, so we want to see what type of triangle is this. Okay, so can you understand the angles at a circle, angles at a point adds to 360. So we can say each of this angle are equal. I'm going very slowly so that you understand. Each of this angle are, so let us say that all the angles, say this is say Z, this will also be Z, this will also be Z. So can I say 6Z is equal to 360? So how much is Z? So Z I can say is 60 degree. So each of this angle, so let me remove the Z now. So each of this angle is how many degrees? Is 60 degrees. So this is 60 degree, and these two angles, this angle plus this angle is 120 degree. They are okay. Now I'll explain that in a different way. Okay. Now how can I do this? I want to find this angle and this angle. Okay. So we know that these two sides are equal. These two sides are equal. So we can say that, well, if this is A, this has also to be A, because they are the base angle. Now we can say they seem to be isosceles triangle. Okay, so because the the distance from here to here is equal to the distance from here to here. Okay, so I can say that A plus A plus 60 is equal to 180. Does it make sense? The three angles of a triangle adds to 180. So 2A is equal to 120. So A is equal to 60. So basically this has become, so if A is 60, this has become an equilateral triangle. Okay, so this is 60, this is 60, and this is 60. So now we are interested to find the area of one triangle. I'll find the area of one triangle. And if I multiply that with 6 or by 6, I get the area of the hexagon. That's my idea. That's what is going to happen now. So we want to find the area of this triangle, equilateral triangle. So we already know, let me change color. We already know this is 5 centimeters. So as all the angles are equal, the sides are also equal. Does that make sense? So if this is 5, I can say this is also 5, and this is also 5. So let me draw an equilateral triangle just to clear the mess. So this seems to be an equilateral triangle. So let us say this is an equilateral triangle. Okay. So this, imagine this triangle I have taken out. So this is the triangle. So we are talking about this triangle where all the sides are 5 centimeters. So this is 5 centimeters. This is 5 centimeters, and this is also 5 centimeters, and all the angles are equal. Equiangular triangle are equilateral triangle. Okay, if all the sides are equal, all the angles have to be equal. Okay, so I want to find the area of this triangle. So what I'm going to do is I'm going to drop a perpendicular from here to here. So we have got this is a right angle. Okay, and this are equal. So you can say if this is 5, this is this would be 2.5, and this would be, oh, you don't need that. Okay, you don't need that. Okay, so yeah, we know this angle is 60, this is 90, so this has to be 30. Okay, you also don't need that. Okay, so we only know this information. Okay, this is of course 30. So I want to find the area of a triangle. I need the base, which is already, this is the base, which is 5 centimeters. I want to find the height. So this is my h, which is the height. So I'm going to use SOHCAHTOA. So here, this is for this angle, this is the opposite, and this is the hypotenuse. So I'll draw the SO triangle. So this is my SO triangle. So, okay. So is opposite, is the sine is opposite over hypotenuse. So opposite In this case, the opposite that we have is O is S times H. Okay, now O is opposite, so O in this case is H, and S stands for the sine of the angle. S stands for sine. Sine is 60 times hypotenuse, which is 5. Okay, so the hypotenuse, now sine 60, without the calculator, you can watch my other videos where I have explained why sine 60 is root 3 over 2 times 5. Okay, so H is 5 root 3 over 2. Now just to explain how I know, or just to check whether this answer sine 60 is root 3 over 2, I'll show this on a calculator. Okay, so let me move this. This is my graphic calculator. So I'll go to run, and then I'll change my setting to degrees because my calculator works on radians by default. So this is my degree, and then I'll show you sine 60. On the calculator is this crazy number, which is nothing but root 3 divided by 2. This and this are the same. Okay, just 2. But this is more exact than this. This is called the third form. Okay, I'm not going into much detail. So here, so the area of the triangle, so I can say area of triangle is 0.5 or half times base times height, which is, you can say this is half times your base is 5 times 5 root 3 over 2. So this is 25 root 3 over 4. Okay, so this is 5 over 1, this is 5 over 1. So I multiply the numerators, which is 5 times 5 is 25, root 3 over 2 times 2 is 4. So area of one triangle is 25 root 3 over 4. Okay, therefore area of the hexagon, you got 6 triangles of this type, so you go 6 times 6 over 1 times 25 root 3 over 4. Okay, so you can simplify what goes, you can simplify 6 and 4, so 2 goes in 6 3 times, and 2 goes in 2 times. So this is simplified to 25 times 3 is 75 root 3 over 2. So if you want to write this, this is as a decimal, this is 75 times root 3 equal, and then divide by 2. Am I doing something wrong here? Just to confirm, I think I'm doing something wrong. I'm not sure. So let me check. Root 3 over 2. Yeah, hypotenuse is 5. Yeah, there's nothing wrong here. So an area of a triangle is base is 5, 25 root 3 over 4. That's right. And you've got 6 triangles, so multiplying by 6. So 2 times 3 is 6, and 2 times 2 is 4. 25 times 3 is 75. Okay, I think I'm right. So this is divided by 2 is 64.95 into 95 centimeters squared. Okay, that is 64.95. So this is 64.95 centimeter squared in 2 dp. See you in the next video.